So here we want to look at the sum of cubes formula. Sum of cubes. So a sum of cubes means you start with 1 in cubit, and then to that you add 2 in cubit, and you add to that 3 in cubit, and so on and so forth until you reach your last number n and cube that. So it turns out that when you add a sum of cubes up to n cubed, the outcome is going to be n times n plus 1 divided by 2, and all of that's going to be squared. And this is true for any n greater than or equal to 1. So for example, if I wanted to find the sum of the following cubes, let's say I wanted to find 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed and so on and so forth up to 100 cubed. So my n here is going to be 100. It's going to be my n right here. That's right. That's my stopping number that's cubed. So n here is going to be 100. So into our formula here, the outcome, we're going to have 100, that's the n, times 101 divided by 2, and then we're going to afterwards square all that. So let's see, if I take 100 and multiply it by 101, I'm going to have 101 and 2 zeros. So that's 10,100. Divide that by 2, let's see, we're going to divide that by 2, that's going to be 5,050. Okay, 5,050, and then let's see if I can back that. Then we have to square 5,050. 50 squared, let's see. Do that. I'm going to get 2550, 2500. It's going to be 25,502,500. So that would be the sum of the first 100 cubes. 1 cube plus 2 cube plus 3 cube plus 4 cube, all the way up to plus 100 cubed. So we definitely wouldn't want to do that by hand. So rather than adding each of those cubes up, we use the quick shortcut formula. So we want to show where this formula comes from. So let's show where this formula comes from. So I guess I'm going to do a little proof of this formula. So the first thing I want to note is that in general, if I have k to the 4th minus k minus 1 to the 4th, I'm going to start with k to the 4th. I'll just copy that down, and I'm going to focus here on this k minus 1 to the 4th. If we expand that through binomial expansion, do a what do you call a Pascal type triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. We have a fourth degree here, fourth degree expansion of this binomial. I'm going to have start with k to the 4th, and then minus 4k to the 3rd, and then plus 6k squared, and then minus. I get a minus there, minus 4k, and then plus 1. That's what would k minus 1 to the 4th power would be if we expanded that out, multiplying k minus 4 times k minus 4 times k minus 4 times k minus 4, repeatedly foiling that, I guess you could say. So notice here that the k to the 4th and the k to the 4th are going to cancel, and we're going to be left with here, it looks like a positive 4k cubed, right? The blue negative sign distributes, we're going to get positive 4k cubed minus 6k squared plus 4k minus 1. So that's what k to the 4th minus k to the 1 to the 4th is equal to. Okay. So I'm going to take an, I'm going to say let an be the following. I'm going to take 1 to the 4th minus 0 to the 4th. So that's when k is equal to 1. And then plus, I'm going to plug in 2 for k. I'm going to have 2 to the 4th minus 1 to the 4th. I'm going to let k be equal to 3. I'm going to have 3 to the 4th minus 2 to the 4th. And I'm going to let k equal to be 4. K is going to be 4. I'm going to have 4 to the 4th minus 3 to the 4th. I'm going to keep that going. Keep that going. I'm going to erase my little Pascal triangle here. Helpful thing. All right, and we're going to go all the way up to n. So we're going to plug in for place of k, we're going to plug in an n. So we're going to have, finally here at the end, well, if I can get it, we're going to have n to the 4th minus n minus 1 to the 4th. So that's plugging in 1 for k, 2 for k, 3 for k, 4 for k, and so on and so forth, all the way up to n for k, and plugging that into the formula and adding those terms up. That's on the left-hand side. That would be this side right here. Plugging in 1, and then 2, and then 3, and then 4, and then all the way up to n, and then adding those terms up. Now, let's see what happens. Notice here 1 to the 4th. Oops. That was not supposed to erase. This positive 1 to the 4th cancels with this negative 1 to the 4th. This positive 2 to the 4th cancels with this negative 2 to the 4th. This positive 3 to the 4th cancels with this negative 3 to the 4th. This positive 4 to the 4th is going to cancel with a negative 4 to the 4th, which you don't see, but it's going to be in there as things continue. And this negative n minus 1 to the 4th, this dude is going to cancel with the positive in front of it. So all you're going to have left for a sub n here is minus 0 to the 4th, right? There's not a positive to the 0 to the 4th in front of it to cancel with. And then plus, you're going to have n to the 4th. This n to the 4th here, or this one right here on the end, it doesn't have a negative n to the 4th after it to cancel with. So basically, all you have left is negative 0 to the 4th plus n to the 4th. So that's n to the 4th. So an is going to be n to the 4th. So that's looking at it from the left-handed perspective, where you plug in 1, 2, 3, 4, and so on up to n, and then add those terms up. Add those terms up. Now, looking from the right-handed perspective, let me get red here. I can also look at an from this right-hand side perspective. This one I'm putting in a box where I'm going to plug in 1, 2, 3, 4, and so on up to n, and then add those up. So I'm going to plug in 1. I'm going to have 4 times 1 cubed minus 6 times 1 squared plus 4 times 1 minus 1. So that's plugging in 1 for the k. Then let's add, and let's plug in 2 for the k. 4 times 2 cubed minus 6 times 2 squared plus 4 times 2 minus 1. That's plugging in 2. Now let's plug in 3. We got 4 times 3 cubed minus 6 times 3 squared plus 4 times 3 minus 1. That's plugging in 3 for k, and you keep going. Let's plug in 4 for k. 4 times 4 cubed plus, minus, right? That's a minus. Minus 6 times 4 squared plus 4 times 4 minus 1. So that's plugging in 4, and you keep going. See if I can scroll a little bit. Dot, dot, dot. You keep going until you plug. So we plugged in 1, 2, 3, 4 for k. Now we're going to plug in n for k. So we're going to have 4 times n cubed minus 6 times n squared plus 4 times n minus 1. Okay, so that's plugging into the right-hand side there. 1, 2, 3, 4, all the way up to n, and adding those together. Now let's see what we can do here with this a sub n. So these, I use purple here. These first terms with the 4 times something cubed, notice we have 4 times 1 cubed, 4 times 2 cubed, 4 times 3 cubed, 4 times 4 cubed, and so on and so forth, 4 times n cubed. We can factor out a 4. They all have a 4 in common, and we'll have what? 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed, and so on and so forth, up to n cubed. So we factor out a 4 out of all those. So next, Notice we have minus 6 times 1 squared, minus 6 times 2 squared, minus 6 times 3 squared, minus 6 times 4 squared, and so on and so forth, minus 6 times n squared. So out of those, we're going to factor out a minus 6, a minus 6, and we're going to have 1 squared plus 2 squared plus 3 squared plus 4 squared, so on and so forth, up to n squared. That was for the blue terms. Okay, we're going to continue. Notice we have here 4 times 1, 4 times 2, 4 times 3, 4 times 4, so on and so forth, 4 times n. So those all have a 4 in common, so I'm going to factor out a 4. I'm going to write my numbers 1 plus 2 plus 3 plus 4 plus so on and so forth plus n. And then finally here at the very end, notice that we have a negative 1, a negative 1, a negative 1, a negative 1, and so on and so forth, a negative 1. So they all have a negative 1 in common. When you factor out the negative 1, you can say you have 1 plus 1 plus 1 plus 1 a bunch of times. It turns out that there are n copies here, n summands of 1. I spell summands right? Let me spell it better. This pen everything kind of goes together. N summands. Now, that's another name for an. So we have an is 4 times. So we're trying to figure out what this purple is. We're trying to figure out what this purple is here. So we want to solve for this at some point. Eventually we want to get this purple by itself. Minus 6 times, okay, so that should be red, minus 6 times. So in class, we already showed what 1 squared plus 2 squared plus 3 squared plus 4 squared and so on and so forth plus n squared is. We showed that was n times n plus 1 times 2n plus 1 over 6. We've already shown that in class, so we've already proven that, so we can assume that here. Keep going, plus, next line, thank you, plus 4, and then in green, we've seen this before, 1 plus 2 plus 3 plus 4 and stuff, so on and so forth, plus n. That's just your standard triangular number, your nth triangular number. We know the formula for that is n times n plus 1 over 2. And then we have minus 1. And then 1 plus 1 plus 1 plus 1 plus 1 plus 1. N summands is going to be n. Okay, so in other words, an is going to be 4 times this sum of cubes, 1 cube plus 2 cube plus 3 cube plus 4 cube plus n cubed. So notice that the 6 here and the 6 here are going to cancel, so we're going to have minus n times n plus 1 times 2n plus 1. The 6 is gone on bottom. Okay, here we're going to have 4 over 2. That's just going to give us a 2. So we're going to have plus 2 n times n plus 1. And notice we're going to have negative 1 times n is going to be minus n. Now, what was the left-hand version of that formula? Remember we said it was n to the 4th, right? Back here, remember we said that another name for an is n for n to the 4th. We calculated that earlier. So what I'm going to do, I'm going to set these equal. I'm going to say, so on the left-hand side, so thus, a sub n here we said is n to the 4th. N to the 4th is equal to 4 times, this is what we're trying to show. We're trying to get this by itself. 1 cube plus 2 cube plus 3 cube plus 4 cube plus n cube. We want to get this purple by itself at some point. minus n times n plus 1 times 2n plus 1 plus 2n times n plus 1 minus n. Okay, this is not too pretty. Okay, let me put this n back in there. There it is. So what I want to do, I want to get the purple by itself. I want to solve for the purple. So on the left-hand side, I'm going to have n to the fourth. I'm going to keep my n to the fourth. That was the yellow stuff. And let's add this one to both sides. We'll have n times n plus 1 times 2n plus 1. Oops, that should be blue. Blue, please. Okay, and let's see, this dude right here, we're going to subtract that, so we're going to have minus 2n times n plus 1. And this one right here, we're going to add that, so we'll have plus n. That's going to be on the left side, and then on the right side, we're going to have 4 times the sum of cubes. Trying to solve for the sum of cubes here. 1 cube plus 2 cube plus 3 cube plus 4 cubed plus so on and so forth plus n cubed. Okay, so I'm going to basically divide both sides by 4 here. And I have n to the fourth plus n times n plus 1 times 2n plus 1 minus 2n times n plus 1 plus n. And we're going to divide everything by 4 so we can get the sum of cubes by itself. Finally, we got the sum of cubes by itself. 1 cube plus 2 cube plus 3 cube, so on and so forth, plus n cube. Okay, now what I need to do, I need to simplify my left-hand side a little bit. Okay, so how does this work? So notice here that the first term, n to the fourth, the second term, so the first term, n to the fourth, has an n. The second term, this dude, this one has an n right here. The third term, this one, has an n right here. And the fourth one has an n right here. So they all have an n and an n in common. We're going to pull an n out. And when we pull an n out, what are we going to be left with? We're going to be left with n to the third plus n plus 1 times 2n plus 1 minus 2 times n plus 1 plus 1. That's what happens when we pull a red n out of those 3 terms. Now this is all over 4. And this is all equal to that sum of cubes. 1 cubed plus 2 cubed plus 3 cubed plus n cubed. All right, so what I'm going to do, I've already factored out that red n. I'm going to work on the blue stuff. The blue stuff. Let's see. I'm going to expand. I'm going to FOIL n plus 1 times 2n plus 1. So let's see. When you FOIL that out, let's see. What are you going to get? You're going to get 2n cubed plus 3n plus 1. Yeah, so that's when I FOIL this out right here. I'm going to get this. Okay, and if I do a little bit of distribution here, right here, the minus 2, I'm going to get, let's see, minus 2n minus 2. That's what happens when I distribute the minus 2, and then we're going to have a plus 1. That's all over 4. And of course, that's equal to the sum of cubes over here. 1 cubed plus 2 cubed plus 3 cubed, and so on and so forth. Plus n cubed. Okay, so I wanna do some combining like terms. So notice this 1 and this 1 cancel with this minus 2. So how do I want to say it? This one and this one make positive 2. They're going to cancel with that negative 2 there. So these cancel. Right? 1, negative 2, and positive 1. If you add them up, they cancel. So you're going to have a n. You're going to have an n cubed plus 2n cubed. I'm sorry, that's a n squared. I messed up, didn't I? I messed up. It should be an n squared right there. N squared. Okay, that's a typo. Yeah, so that when I FOILed that out, it should have been 2n squared plus 3n plus 1. When I FOILed out the green, n plus 1 times 2n plus 1, it should have been 2n squared plus 3n plus 1. I should have n cubed plus 2n squared plus 3n. We said the 1, negative 2, and 1 canceled, and you say you have a minus 2n. Okay, so this is a 3n right here. Okay, so let's combine those terms. Let's see, what color can I pick here? Orange? Oh, orange. Let's combine here the, golly. This thing is annoying. Let's combine the 3n here with the minus 2n. There we go. I want to combine those. 3n and minus 2n is going to give me just a positive n. And all that's over 4. And all that's equal to, hold up. There we go. 1 cubed plus 2 cubed plus 3 cubed plus so on and so forth. Plus n cubed. Okay, so I already have an n factored out, but notice also here, each of these terms, n cubed, 2n squared, and n all have an n in common. So we're gonna take an n out of those, factor out an n out of those, and when we factor an n out of those, we're gonna be left with, let's see, n squared plus 2n plus 1, and that's all over 4. That's a 4 right there. And that's all equal to 1 cubed plus 2 cubed plus 3 cubed plus n cubed. And if I factor, okay, so I do here n times n, right? I do n times n, that's going to be n squared. And if I factor the blue, I'm going to have n plus 1 squared, right? N times 1 times n plus 1 is n squared plus 2n plus 1. And that's all over 4. And that's equal to the sum of the cubes. 1 cubed plus 2 cubed plus 3 cubed plus so on and so forth plus n cubed. In other words, I can write this side over here as something squared. I can write this as n times n plus 1 over 2, all of that squared. And that is precisely what we wanted. We wanted n times n plus 1 over 2 squared, which is the sum of cubes, 1 cubed plus 2 cubed plus 3 cubed, plus so on and so forth, plus n cubed. So that's a good formula to have. So I've established this formula, so you don't have to establish, so now you can use it. You can use this formula whenever you want now.